Okay. Why did the pirates dump marijuana into the ocean? Because they wanted to sail the high seas. All right. So we can find domain and range from graphs. Domain's all the inputs, range is all the outputs. We just look, well, what's the furthest to the left we can go? What's the furthest to the right we can go? That's the domain. What's the furthest down? What's the furthest up? Do we have everything in between? That's the range. From formulas, it can get a little bit more complicated. And it's funny because it can get so complicated that really we're just going to look at simple things and only for the domain. We're not going to find the range from these functions, not in this class, which is great because I hate explaining that. So we're just going to focus on domain. And for the domain, so two common restrictions for domain are going to be that the square root of negative values is non-real. So that means that when we're looking at domain, if we have a square root, we're going to want the inside of that square root to be at least 0. The other thing we look at, so again, this is for square roots. The other thing we look at is for fractions. Because we cannot divide by 0. So if there's a fraction, we need to make sure that the denominator of that fraction, the bottom of that fraction, is not 0. So let's see what this looks like. Let's look at this first example. What's the domain? Well, domain is all the input values that make sense. So if there's a square root, we think about what can cause problems here. Well, if the inside's negative, then we're not real anymore. So we need the inside of the square root. We need this to be at least 0. That's how we find our domain. If the inside is at least 0, everything's fine. That's going to be how we solve our domain. So we're going to say, well, x plus 4 has to be at least 0. What does that mean for x? We have a linear inequality to solve. So we're going to subtract 4 from both sides and get that x has to be at least negative 4. We'll write that in interval notation. Our domain says that x is at least 4. On the number line, what does that look like? If 4 is here, that means x is either 4 or any number bigger than 4. So 4 and all the way to the right. So the smallest we can be is 4. The biggest number we can be is infinity. Infinity is never included. The 4 will be included because of that equal sign. Really loving this purple. I might do this forever. That's our domain. We just look for square roots. We look at for fractions and force what we want. We want the inside of a square root to be at least 0. And we want the denominator of fractions to not be equal to 0. All right, so let's see how that manifests itself in the second one as well. This is another function called g. This function says you take 3 and then divide that 3 by 6 minus 3x. So there's no square root, so we don't have to worry about this first condition. The only thing there is a fraction, so we have to make sure that the denominator is not equal to 0. So we need the denominator, which is 6 minus 3x. 10, that's an x that looks good. We need that denominator to not equal 0. Well, we got to solve this inequation, this unequation, not equal to. So we'll get the 3x by itself. You can add 3x to both sides. That gives us that 6 can't equal 3x. And then we can divide both sides by 3. 6 divided by 3 is 2. 2 cannot equal x because these 3's cancel. Okay, so everything that's not 2 works. Our domain is everything that's not 2. How do we write that in interval notation? Well, let's graph it. We have a number line. Say 2 is here. We cannot be 2, so let's draw an open circle. But we can be bigger than 2. We can be smaller than 2. Oh, this is like the practice we were doing where we've got 2 pieces. 2 pieces. So let's start with the piece on the left. The piece on the left can be as small as negative infinity and as big as 2. 2 is not included. Negative infinity is never included. Shed a tear for negative infinity. And then the piece on the right, well, the smallest it can be is 2. And the biggest it can be is infinity. Infinity is never included either. And 2 is also not included. And then we connect these 2 pieces with a union sign. It looks kind of funny because it's just a funny way of saying this. But that's how we write it in interval notation. And I hope you're saying, Jason, you said interval notation was a shorthand, but the thing on the left is way longer. Well, there's another shorthand that we're skipping called set builder notation. That makes us look a little nicer, but I don't think y'all need it, so we're just going to be consistent with the interval notation. And then I forgot to add white space here, but try it now. Pause the video. This one's going to be tricky because you got a fraction and a square root, but I believe in you. Give it a try. Really don't have white space. Pause the video, and then let's see if we can do it together. Okay, so we got 2 things. We need the inside of the fraction. Wait, this is even a different purple. We need the inside of the fraction to be at least 0. And inside of the square root to be at greater than or equal to 0. And we need the denominator to not be 0. So we have both of these. And you can solve both of these the same way that we did it in parts A and B. So this first thing, what this becomes, is that x has to be at least -5. The second thing, what this becomes, is that x can't equal -2. So what does that look like on the number line? Well, we're going to need something at -5 is going on and something at -2 is going on. X has to be at least -5, so everything to the right of -5, but we're skipping 2. X cannot equal 2. So this is what we look like on the number line. And this is going to be a similar situation where we have 2 pieces. So the piece on the left says that the smallest we can get is -5, and the biggest on the left piece is -2, which isn't included. We're combining this with the piece on the right that says that we're at bigger than -2, and that we can get as big as we'd like. This is our domain here. This one's a little trickier for a try it now problem, but hope you did okay, and you can let me know if you have more questions, and hope you're ready for more pirate jokes.